Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about ratio. So a ratio is a comparison, usually of two measurements, but it could be more than two. And when you compare those two measurements, they have to be in the same units. Once you have the two measurements in the same units, you can drop the units. So a ratio is a comparison of two or more measurements. Before you can compare, they have to be in the same unit. Once they're in the same unit, you drop the units and your ratio doesn't have any units at all. So for example, if I had a measurement of 25 centimeters and I was comparing that to 10 centimeters, their lengths are in the same unit, so I drop that. That will be a ratio of 25 to 10. A ratio can also be considered a fraction, so we can think of 25 to 10 as 25 over 10. And it would follow the same rules of simplification. We wouldn't leave a fraction like that, we would simplify it. Similarly, we wouldn't leave a ratio like that, we would simplify it. So you want to simplify your ratios just like you simplify your fractions. And the way you do that, if there's a number that can be divided into both numbers in the ratio, you can go ahead and do that and the ratio stays the same. Just like here, we could divide numerator and denominator by 5 and we would get a fraction of 5 over 2. We can do the same thing here. As long as we're dividing both numbers in the ratio by the same thing, it stays in an equivalent ratio. So 25 divided by 5 is 5. 10 divided by 5 is 2. So if we were comparing a length of 25 centimeters to 10 centimeters, we would say that those lengths are in a ratio of 5 to 2. So let's take a look at some examples of simplifying ratios. If we had 1.2 meters to 50 centimeters, these are not in the same unit. I can't compare them until they are. So I'm going to change 1.2 meters to centimeters. And that will be 120 centimeters to 50 centimeters. Once I have the same unit, I drop the unit and I'll have 120 to 50. Now I look to see if there's any number that divides into both numbers in my ratio. I can divide both numbers by 10. So I'm allowed to do that and I will get 12 to 5. Can it be reduced any further? No, there's nothing that divides into both 12 and 5. So that would be my simplified ratio. If you have fractions or decimals in your ratio, you don't want to leave them there, just like you wouldn't want to leave them in a fraction. So what I'm going to do, in this case, because I can change 1 1/4 to a decimal, I'm going to change it to a decimal. So this would be 5 to 1.25. Now, if I had that as a fraction, the way I would simplify it is I would get rid of my fraction in the denominator by multiplying numerator and denominator by 100. And then I would get 500 over 125. I'm going to do the same thing with my numbers in a ratio. I'm going to multiply each of these by 100 so that I don't have a decimal in my ratio. So 5 times 100 is 500, and this will be 125. Now I look to see if I can reduce this. 125 actually divides into 500 4 times, and 125 divides into 125 1 time. So I divided by 125. I get the same result as I would have if I had reduced that fraction. I could simplify this to 4 over 1 as well. So if you have a fraction in your ratio, deal with it either by changing it to a decimal if it turns into an even decimal. And if it doesn't change to an even decimal, you're going to have to keep it as a fraction, but you're still going to have to reduce. Let's do an example of that. If you have the ratio of 1 1/6 to 2 1/3, you can't change to decimals because they don't, 1/6 and 1/3 are not even decimals. and you're going to have to start rounding off, and your ratio will not be correct. So there's two ways that you can work with this ratio. You could think of this as a fraction, 1 1/6 to 2 1/3. So that means you have 1 1/6 divided by 2 1/3. The way you divide fractions is you need improper fractions. So this will be 7/6 divided by 2 times 3 is 6 plus 1 is 7/3. And then the way you divide fractions is you multiply by the reciprocal of the divisor. So you multiply by 3/7. We can cancel. The 7 divides into the numerator once, into this denominator once. Then we could cancel a 3 into there once, a 3 into there 2. And we end up with 1/2. And we can express that as 1 to 2. So that's one way we could simplify this ratio. The other way, you still need to change to an improper fraction. So this is 7/6, and this will be 7/3. And then I could multiply both fractions by the lowest common denominator, which would be 6. So we times it by 6/1. We times it by 6/1. The 6 cancels, so we'll have 7. The 3 cancels, we have a 14. And now I'm going to divide both of these numbers by 7, so I'll get 1 to 2. So both approaches will give you the same result. It's a matter of which one you found easiest. So when you're simplifying ratios, make sure they're in the same units before you start. Then you can drop the units and simplify. If there's anything common that can be divided into both numbers, just like fractions, you're going to divide. If there's decimals, you need to get rid of the decimals. And if there's fractions, you need to get rid of the fractions. Now let's take a look at working with ratios. Sometimes you'll be given a ratio and you'll be asked to find other values. For example, if we had gas and oil mixed together in a certain engine in the ratio of 15:1, we could be asked how much of one of them is needed when we know how much of the other substance is being used. So for example, how much oil must be mixed with 10 liters of gas? When it's written in this form, gas and oil are mixed in a ratio of 15:1, that means that for every 15 parts of gas, there's 1 part of oil. So you have to keep the order correct. And if we have a ratio of 15:1, we can write that as a fraction. The ratio of gas to oil has to stay the same in that engine. When we mix 10 liters of gas with a certain amount of oil, we have to keep that ratio. So the numerator represents gas to oil. So if we've got 10 liters of gas, we put that in the numerator. And the denominator, we don't know. We don't know how much oil. But that ratio of those two numbers still has to equal 15:1. Now we can cross multiply. So 15x will equal 10. 15 times x will equal 10 times 1. Divide both sides by 15. So x will equal, and let's change it to a decimal, 0.666. We can round that off to 2 decimal places, 0.67. So the amount of oil will equal 0.67 liters. I rounded off, and now it's not exact, but we don't keep fractions when we're working with metric units. So that's one question that could have been asked, is if you know how much gas or oil, how much of the other one? There's another type of question that you could be asked when you're working with ratio, and let's take a look at that. We're still going to work with this gas and oil mixture, but this time, instead of knowing how much of one and finding out how much of the other, instead we're asked how much of each is required to fill an 8-liter tank. So this is a challenging question, and students typically have lots of difficulty with this. So I'm going to show you how you can approach it to get the right answer. What you need to do is think of the ratio 15 parts gas to 1 part oil. So in total, we have 16 parts. Now the fraction of the total that the gas will be 15 out of those 16 parts. The fraction or portion of that mixture that will be oil will be 1 part out of that 16. So what I'm going to do is take my full tank, 8 liters, and multiply by those fractions. So the amount of gas will be 8 liters times 15 out of 16. When I multiply that, I can cancel the 8, and I'm going to get 15 divided by 2, which would be 7.5 liters. I do the same thing for the oil. I take 8 liters and multiply by the portion that's oil, which is 1 out of 16 parts. Again, I can cancel. 8 goes into there once, 8 goes into there twice. So 1 times 1 over 1 times 2, which is 0.5. So in order to mix the gas and oil in the correct ratio of 15 to 1, to fill an 8-liter tank, I need 7.5 liters of gas and 0.5 liters of oil. We could check to see if this is the correct ratio by just taking 7.5 to 0.5, getting rid of our decimal point, so that's 75 to 5. Divide both sides by 5, and I get the correct ratio. So it can get tricky with ratios. Make sure you read the question carefully. Understand whether they're giving you one of the components and asking for the other, or if they're giving you the total and asking for each of the components. Practice as many questions as you can dealing with ratio, and we're going to move on to something that's related to ratio next, which is proportion. Take care and see you then.